everyone, I hope you find you well. Today's lesson will be chemical kinetics, the collision theory. What is chemical kinetics? The study of the rates of the mechanism of the reaction. Concerns how rate of chemical reactions are measured, how they can be predicted, and how reaction rate data are used. The collision theory. For a reaction between two particles to occur, the particles must collide and the collision must be effective. A matter thus consists on moving particles. As the temperature increases, the particles move faster and collide more often with more energy. In the chemical reactions, bonds must be broken and new ones are formed. The energy for this comes from particle collisions. The collisions have a variety of energy, as some are more harder than others. A collision energy diagram is a graph of the number of the collisions versus the energy of each collision. You need a collision to have a reaction. Collisions provide the energy required to break bonds. Most collisions are not successful. A collision requires favorable geometry. We have the first part, which are two vertical molecules that bump with each other or collide, as we just learned, and they form new products, versus a poor geometry. If we have two linear compounds, they collide with each other but they don't form new products. You need a collision to have a reaction. Collisions provide the energy required to break bonds. Most of them are not successful. A successful requires a sufficient energy to break the chemical bonds. The activation energy, as we mentioned on the previous lessons, is the minimum amount of energy that requires for a successful collision. Here we have a graph. The activation energy, as I said, was the minimum energy required for successful collisions to break the bonds. On the blue area, this area represents the fraction of collisions with the energy of activation that is successful. Lowering the energy of activation, increasing the successful collisions. Increasing the temperature increases the successful collision, increases the rate, and the graph is pushed down and right. The other area represents the fraction of collisions that do not have an energy of activation not successful. Now, the collision theory can be used to explain how rate of a reaction can be changed. Reaction rates can increase due to more collisions, harder collisions, greater collision energy, lower activation energy, which allows low energy collisions to be more effective, and that's it. Increasing the temperature increases the rate because there are more frequent collisions, harder collisions. Increasing the reactant concentration increases the rate because there are more frequent collisions. Adding a catalyst increases the rate because lower activation energy, which allows low energy collisions to be successful. Changing the nature of the reactant for a more reactive chemical changes the rate because the lower activation energy, which allows low energy collisions to be more effective. Increasing the surface area of a solid reactant increases the rate because more frequent collisions. An example: a balloon full of hydrogen and oxygen do not react at room temperature. The activation energy is too high for the room temperature collisions. A small spark ignites and causes an explosion. The spark provides the activation energy and it explodes because it is exothermic. A candle does not burn at room temperature. The activation energy is too high for the room temperature collisions. A match causes the candle to burn. The match provides activation energy. The candle continues to burn. It burns because it is exothermic. Hydrogen peroxide decomposes very slowly at room temperature. If we use potassium iodide, increases the reaction rate dramatically. Potassium iodide is a catalyst and it is not a reactant, and it speeds up the rate, lowers the activation energy, which allows low energy collisions to be more effective. Here we have the graphs. Decreasing the energy activation increases the rate inverse. Increasing the temperature increases the rate direct. Increasing the concentration increases the rate direct. Energy activation and the temperature, the only way to change the energy activation is by adding a catalyst. No relationship. Reminder, on 9th April we will have the exam. If you have any questions, do not hesitate to write me through email and we can set up a Zoom class to do the revision. Thank you.